All right, number 51 says, which best represents the graph of y equals 2x minus 5? And here we have four choices for this graph. Now, the thing we need to understand with this one is that we need to understand that this equation is written in y equals mx plus b form, where m is your slope and b right here is your y-intercept. So knowing that, we know that our slope for this equation is 2, and that's illustrated right here in the equation. And our y-intercept is negative 5. So let's go ahead and find our y-intercept first. So we know our y-intercept is negative 5, so we know that this line to this graph should cross the y-axis at negative 5. So negative 5 is right here on all these graphs. I'm just going to circle all of them to show you which ones are crossing there and which ones are not. So obviously right away you can see that for A, the line does not cross at negative 5. It crosses at negative 5 on the x-axis, but it's clearly marked x right here. The y-axis is right here. So it does not cross this one. It is not A. It also does not cross B. Nowhere is a line even touching anywhere negative 5. So we have two options. We just eliminated two of them. We have two options left, which is C and D. They both cross the y-intercept at negative 5. So since we already used that, now the only thing left to do is use the slope. Now we have to use the slope to figure it out. So the slope is 2. Now what does that mean the slope is 2? Well, earlier in the year, I taught you guys that slope was equal to rise over run, which means that it rises when it rises that or falls, that's the numerator, and when it goes right or left, that's the denominator. So the slope is equal to 2. So the slope is equal to 2. But I know what you're thinking. Rise and run, it's written as a fraction right here. Then how come this number down here, the number 2, is not written as a fraction? Well, we can make it into a fraction. We should turn it into a fraction, really, because it should be written in rise over run form. So let's go ahead and put it over 1, because that's how you turn any number into a fraction. So here's your slope. That means that it's going to go up 2, and it's going to go up because it's a positive number. And then it's going to go to the right 1, because that's your denominator, and it is also a positive number. If it was negative, if your numerator was negative, it would go down. If your denominator was negative, it'd go to the left. So now let's go ahead and test this on our graphs and see which one of these is our correct slope. So let me go ahead and erase this part right here so we can see it better. All right, so here we go. So I'm going to start at this point at our y-intercept, since I know it's our y-intercept for both. So I'm going to start with C first. Now, according to our slope over here, we know that it rises twice and then goes to the right once. So here we go. 1, 2, that's twice, and now runs over to the once to the right. Now it looks like it's still on the line. Let me try it again. 1, 2, and 1 to the right. So it clearly is on the line. I can already tell that C is my answer. I'm just going to check D to make sure it's definitely not. So before I circle it, and I just want to be 100% sure. So 1, 2, and 1 to the right. As you can see, it's not touching. And when I do it again, you can clearly see it is off mark. So D is not your correct answer. Our correct answer here is C. All right, number 52 says, what is the slope of this line? So as you can see, it's pretty much we can do it the same way we did it in the last problem, where we can do slope equals rise over run. There are two ways to do this one. Let's do rise over run first. A lot of you guys like doing it this way. And that's fine. So let's go ahead and do this. Now, in order to do rise over run, we really just need to understand one thing. That we definitely want to find 2 points on the line to do rise over run. So we need to connect those 2 points. We need to go up or down or whatever it takes and to the right or left to get to the other point. So let's do rise over run on this one. So I'm going to start this point down here, -2 and -2. And I'm going to see how far I rise to get to this point over here. So I'm going to go 1, 2, 3. Now I went 3 up, and I should be even with the other coordinate over here, so my rise is 3. It's positive because it went up. If it went down, it would be negative. So it's positive, and now it looks like I'm going to have to go to the right to get to this dot, so I know my denominator is also going to be positive. So let's see how many it takes. 1, 2, 3, 4. So clearly you can see that my rise over run, or my slope, is 3/4, and it's going to be b. Now I want to show you the other way we can do this, and the other way we can do it is by using our slope formula. You should know your slope formula pretty well by now. So remember, the slope formula is m, which stands for slope, equals y, the second y minus the first y, over your second x minus your first x. So I'm just going to go ahead and plug these in. I'm going to consider this one right here my first x, or my first coordinates, and 2 and 1 my second coordinates. So the y in the second one is 1, and I'm going to subtract that from the first y, which is -2. Very important that you put -2. The subtraction sign is part of the equation, not part of the number in this case. My second x is 2, as you can see right here, minus my first x, which is also -1. All right, so now I have 1 minus -2. Remember, when you have two negatives touching or close, separated only by parentheses, that pretty much means that it's addition. So 1 plus 2 is 3. And same thing here on the denominator, you have two negatives that are touching. So you have 2 plus 2, which is 4. And as you can see, I have my same answer, 3/4. My answer is B. I just double checked it. I did two methods in order to solve this. And either one of these will work. If you know the slope formula, y2 minus y1 over x2 minus x1, it'll definitely help you out for the problems we're going to do in the future, more than rise over run. Here we have 53. 53 says, which statement is true about the slope of line AC? So here we have a line. As you can see, it's a totally straight line. So let's find out which statement is true. So it says the slope is the ratio of x and y intercepts. Okay, so let's go ahead and test this out. I don't think it's true because I don't remember learning that at all. But let's go ahead and test this one out. So the x-intercept, as we can see here, is 2. So we're going to put that as our rise, or our ratio. And y-intercept is -2 right there. So 2 over 2, or 2 over -2 equals -1. So it's telling us, if this statement was true, it would be telling us that our slope is -1. Now, one thing you will definitely notice that why this statement is false is because the slope is negative. And you should know that when the slope is negative, the line going from left to right should be pointing down. In this case, the line going from left to right is pointing up, is going up. So you should know that this statement is false. This statement is not true. I'm going to go ahead and cross that one out. So now let's go ahead and read B. B says the slope is the same between any 2 points on the line. Now, what does that mean, any 2 points on the line? So that means that, is the slope the same anywhere you count it from? So if I'm going from A to B, is the slope from A to B the same as I'm going from B to C? And you should know, if it's a straight line, the whole line is going to have the same slope. So I'm going to go ahead and circle this one as being possibly our answer. I know that's correct. Because especially if it's a straight line, you know that it just has one slope. So here we go. Let's go ahead and read C. It says the slope between A and B is greater than the slope from between B and C. So let's go ahead and test this theory out. And if this one's incorrect, it'll prove that B is more correct. So A to B, here we go. Rise over run from A to B. So we're going to A to B right now, and it's 1, 2, 3, 4, 4 high. So we're going 4 up, which means it's positive. 1, 2, 3, and 4 across, which means our slope is 1. Okay, and now it says A to B is greater than B to C, so B to C should be less than 1. Let's find out. 1, 2, 3, 4. Okay, so 4 again, and 1, 2, 3, 4. Okay, so it's the same thing. So C is incorrect. AB is not greater. Let me see. D says the slope between A and point C is greater than the slope between A and point B. That is not correct. We already know that the slopes are the same. Once again, it just reinforces our answer, which is B. All right, number 54 says, what is the slope of the line? So of this line right here, now as you can see, this one's a little more difficult because it doesn't have any points plotted, and it doesn't have the coordinates of any 2 points. So this one's a little bit harder, but once again, we can use it. We can easily solve it by finding the slope by either using rise over run or by using our formula for slope, which is y2 minus y1 over x2 minus x1. You could do it either way, and if you do not know how to do either of these, just watch the previous 2 questions we did, and you'll definitely know how. I'll go ahead and do it both ways once again so we can figure this out. This will not be the last slope problem on this test, so from now on, we'll just go ahead and use either one of these to solve. So let's do rise over run first. So rise over run, I need 2 points, and here it doesn't have 2 points picked out for me, but I'm going to go ahead and pick 2 points. Just make sure that they're perfectly coordinated on a point. As you can see, like this right here is not on a point. It's not exactly on it, I don't think. So I wouldn't pick that. If anything, I would definitely start from the y and the x-intercepts, because I know that that goes right through a specific point. So I'm going to start right here. I'm going to pick this point as my starting point. I'm going to pick this point as my ending point. So I'm going to do rise over run for this one. So I'm going to rise 1, 2, 3, 4, 5. So my rise is 5. My run, I'm running to the right, which means it's positive. 1, 2, 3, 4, 5, 6, 7. So my rise over run is 5 over 7. This can't be reduced. So that's pretty much means that this is my slope. My correct answer is C. I'm just going to go ahead and reinforce that answer by doing the slope formula. So as you can see right here, I'm going to go ahead and mark the coordinates for my points. So for this one, it's -7 and 0. And for this one, it is 0 and 5. So I'm going to use this as my first x and y, and I'm going to use this as my second x and y. So here we go. My second y is 5 minus my first y, which is 0, over my second x, which is 0, minus my first x, which is -7. So here we go. 5 minus 0 is 5. And here we have 0 minus -7. Once again, there are 2 negatives touching each other. If it wasn't for this parentheses, they'd be touching each other, but they're close enough to where you can change it into a positive. 0 plus 7 is 7. Once again, 5 over 7 is our correct answer. 2 different ways to do it. Either way would work good for any of these. All right, let's go ahead and move on to 55. 55 says, which graph shows the line with a slope of 2? So for this one, I'm going to go ahead and use rise run instead of the slope formula. So rise run means that I need to write it in a fraction form, rise over run. So as you know, my slope, they say it's 2. So how am I going to write this in fraction form? Well, it's very simple. I just put it over 1. So 2 is my rise, and 1 is my run. They're both positive once again, so that means that you're going up and to the right. So here we go. I'm going to start from this point on A. I'm going to go up 2 and over 1. So it is not on the line, so it's not A. I'm going to start right here at the y-intercept on this one. I'm going to go up 2 and over 1. It looks like it's on the line. I'm going to try it again. Up 2 over 1. And it is definitely on the line. So I'm going to go ahead and circle C. I'm not positive that that's my answer. I know it has this slope on it, but I just want to eliminate the other 2 before I make up my mind. Okay, now, well, I want to show you what B and D are doing and why I know automatically that those are not my lines. So it says right here in the question that my slope is 2. So 2 is positive, and whenever you have a positive slope like 2, positive 2, that means your line from left to right is going to be going upward. Okay, if my slope was to be -2, that means that my line going left to right would be going downward. So in this case, you can see B and D are both going downward from left to right. That means the slope in there for those 2 lines are negative. It definitely is not those because my slope is positive. So that just confirms that my answer is C. So for 55, the answer is C. All right, here we go. 56. 56 is a really small problem. Let's see if I can get it a little bigger here. So it says bananas are on sale at the price of £3 for $1. Which graph shows the relationship between the number of pounds bought and the total cost? So let's go ahead and do this one then. It says that 3 pounds of bananas, 3 pounds is $1. So what I want to do here is I want to find the unit price for 1 pound of bananas. So 1 pound, and I don't know how much the unit price is. So we have 1 times 1 here. So our answer is 1. We're going to go ahead and divide by 3. And I'm using, in case you don't notice, I'm using a cross product here to solve for what 1 pound of bananas is. So 1 divided by 3. All right. So that's going to be 0. That's going to be 3, 9, and it's going to continue on 3. So it's going to be roughly 33 cents for 1 pound of bananas. So by using cross product, I can figure out that it's 33 cents per banana. So for 1 pound of bananas, it is going to be 33 cents, $0.33. Okay, so let's go ahead and figure this out. It's asking, as if you can see, all the graphs here are 5 and 10 pounds of bananas. So let's go ahead and find out how much 5 and 10 pounds cost. So if it's 33 cents per pound, I'm going to go ahead and multiply that by 5. And that's going to be 15, carry the 1, that's 16. Don't forget to move over your decimal point twice because that's how many it holds. So for 5 pounds, it's going to be $1.65. 10 pounds is going to be twice as much, but let's go ahead and figure that out by multiplying it. Be a lot easier. So 0, 0, 3, 3. All right, so it's 330. Once again, it holds 2 decimal places over, so I'm going to go put that decimal point right there. So 10 pounds of bananas should cost you $3.30. So let's find out which one of these graphs is the correct one. So here we have, let's look at the first one. Remember, 5 pounds is $1.63. So here's $1, $1.63 should be about right there. And hey, look, that lands pretty good on there. So 10 pounds is $3.30, remember? So $3.30, I'm going to guess, is right here. You know what? This one looks like it's pretty dead on. Let me just check the other ones to make sure that it is that one. So let's do the 10 on B. So 10 pounds is $3.30. So as you can see, it's nowhere close. According to this graph, B, $10 of banana should be over $6, and that's just not correct. So I'm going to go ahead and cross that one out. C says 10 pounds is going to give you a lot more. It's even off the charts, so it's definitely not C. And last one, D, if you can see it down there, it's kind of small. Sorry about that. But if you can see D, oh, can't make that bigger. There we go. If you can see D, it says that the price of bananas is the same, $1, with no matter how many pounds you're buying. Even if it's 0 pounds bananas you're buying, it costs you $1, which we know. For those of you that don't go to the grocery store and don't buy bananas, they don't charge you $1 just for not buying any. So that's not correct. So the correct answer for 56 is A, because it matched up with my graph and the prices I got for 5 and 10 pounds of bananas. 57 says, which value of x makes the equation below true? So it says x over 9 plus 6 equals 8. So there's a number of different ways that we can do this one. I like to do it by canceling out the 9 underneath the x. And if you can remember, let's go ahead and write down the equation. I'll show you what I mean. Plus 6 equals 8. Well, first I want to go ahead and move the 6 over because remember, the whole point of solving for x is to get it by itself. So first thing we need to understand is that this plus 6 is bothering x from being by itself. So I'm going to go ahead and move it. I'm going to cancel it out by subtracting by 6, but what I do to one side, I have to do to the other. So I'm left with x over 9 equals 2. So from here, now I just have to get rid of the divided by 9. So a lot of you see this and say, oh, I need to get rid of the 9. Well, if you get rid of the 9, you still have x divided by and then nothing afterwards because you got rid of the 9. You have to make sure that you get rid of the divided by 9. And I always tell you guys, what's the opposite? Because opposite always gets rid of it. What's the opposite of divided by 9? And you should know the opposite of divided by 9 is multiply by 9. So if you multiply by 9, it cancels out the 9 as the denominator. But once again, what you do to one side, you have to do to the other. So now I have x by myself over here, and 2 times 9 is 18, which means the correct answer for this one, what x equals, is 18. Whoa, almost circled the wrong one there. So let's go ahead and test it out and make sure that it works. A lot of us don't necessarily check our work, and we need to make sure we start doing this, especially on a test as important as this. So if it's truly the right answer, it should work out, and it doesn't take that long to test it out. So let's go ahead and do that. So, oh man, I'm messing up left and right. Okay, so here we go. So 9 goes into 18. 9 over 18, 9 goes into 18 twice. So we can simplify that as 2 plus 6. Is 2 plus 6 equal to 8? It sure is. So as you can see, our correct answer was 18. It works out for the whole problem. 8 is equal to 8. So we know that it 100% is B. 58 says, what is the solution set to the inequality 6z plus 5 is greater than 35? So this is pretty easy. This is an inequality problem. We have 6z plus 5 is greater than 35. So for this, it's just like doing an equation. So I'm going to go ahead and erase this greater than, and I'm going to go ahead and put equals, equal to. Remember that it is greater than. Actually, I'm going to move the greater than over here so you can see it. But it is greater than. I'm just replacing it with that so you can see how we're going to do the problem, and it's just like treating it like a regular equation instead of an inequality. So first thing I do, of course, is subtract 5 from both sides. Now I have 6z equals 30. I'm going to go ahead and divide by 6 to get z by itself. 6 goes into 30 5 times. So here we have z is equal to 5. Well, I don't see z is equal to 5, but if you remember, I replaced the equal sign with the, replaced the greater than symbol with the equal sign, so I'm just going to put that back. Our correct answer is z is greater than 5, which means our answer is C. All right, 59 says, what is the value of x if negative 3x plus 2 equals negative 7? All right, I like these kind of problems. They're one of my favorites to do. I like moving numbers. And as you can see, they're very simple to do. It's just simple adding and subtracting and simple division and multiplication. So remember, whenever we're solving for x, we have to get it by itself. And you take away what's farthest away from x first in order to get it by itself on one side of the equal sign. So here we have x over here. We know that negative 2 or positive 2 is bothering it, so we got to get rid of it by finding its opposite, which is negative 2. That's going to cancel out, but what you do to one side, you have to make sure you do to the other. Now we're left with negative 3x equals negative 7 minus 2 is negative 9. Now we have to, we cannot add 3 to get rid of this negative 3x because the 3 is actually attached to the x. It's telling us we have negative 3x's. So since that's happening, we need to divide by negative 3. That gives us 1, or 1x, which is the same as just x. And as you can see here, the problem will equal negative 9 divided by negative 3. You know that two negatives divided by each other makes a positive number. 3 goes into 9 3 times, so our answer is x equals positive 3, which means C is the correct answer. Number 60 says, Joan needs $60 for a class trip. She has $32. She can earn $4 an hour mowing lawns. If the equation shows this relationship, how many hours must Joan work to have the money she needs? So this is our equation here. It's telling us that it's the relationship for this problem. So we're going to go ahead and use this equation. It is 4h minus, or plus 32 equals 60. Now, as you know, the 4 is how much money she gets per hour. The h is how many hours she worked. We don't know, so we use the variable. How many hours she needs to work to get the 60, plus the 32 she already has. So we're just going to do the same thing we did in the last few problems, which is just move around numbers so we get h by itself. So first thing we're going to do is get rid of positive 32, and we do that by subtracting 32. We do that to both sides, of course. So now we have 4h equals, let's see, we need to borrow from there. That's 10 minus 2 is 8, and 5 minus 3 is 2. 28. Now we divide by 4 to get rid of the 4. That's 1h, or just h. 4 goes into 28. That goes into that 7 times. So she needs to work 7 hours, which means our correct answer is A. All right, 61 says, what is the value of, or what value of x satisfies the equation 4x plus 2 equals 22? We should be really good at these by now. There's been so many of these, and like I said, these are one of my favorites to do. They're very easy, and hopefully you get the hang of them now. So remember, take away what's farthest from the x on one side, of course, which in this case is positive 2. So we're going to go ahead and subtract 2 from both sides. We're left with 4x. I'm going to cross that out so you see that. 22 minus 2 is 20. And now we're going to divide by 4. So divide by 4. That cancels out. So we're left with x. And 4 goes into 20, or 20 divided by 4 is 5. So x equals 5, which means x is satisfied by 5. So B is our correct answer. 62 says a duck flew 18 miles per hour for 3 hours, then at 15 miles per hour for 2 hours. How far did the duck fly in all? So we want to know the total distance that the duck flew. Maybe it might be good to draw a picture in this one. I'll go ahead and do it mathematically, but remember, I always ask you guys to draw pictures if you're having trouble visualizing it, and it might be a good idea to draw a picture here. But for me, I'll go ahead and show you how to do it mathematically, which will probably be the best way to do it. So let's go ahead and start with the first sentence, the first set of numbers we have, which is a duck flew 18 miles per hour for 3 hours. So 18 miles per hour, 18 miles per hour means that in 1 hour, the duck will fly 18 miles. And we know that he flew 3 miles in this, going at this speed. So that means that we have to multiply 18 by 3 because it's 18 miles per hour and for each hour, and he flew for 3 hours. So 8 times 3 is 24. Carry the 2. That's going to give us 54. So he went 54 miles going 18 miles an hour. So in 3 hours, he went 54 miles. Now, as you can see, the second part of the problem, he flew 15 miles per hour. I'm guessing he went slower because he was tired. And for 2 hours. And once again, probably didn't fly as fast or for as long because he was tired. He's been flying for a long time, this duck. So once again, we'll do the same thing. 15 miles per hour, which means every hour he flies, it's 15 miles. He flew for 2 hours. So we're going to multiply by 2. We get 30. So that means he flew 30 miles the second time. Now, we're going to go ahead and add 30 miles to 54 miles because it's asking us what is the total that he flew in all. As you can see right here, it says in all. So we're going to go ahead and add these two together. 30 plus 54 is 84. So he flew a total of 84 miles going at 2 different speeds. Our correct answer is D.